Differential seam welder, 150 KVA. On here we have a 10-inch upper wheel, 3.3 diameter lower wheel. We have truncated here with about a 3-inch radius. We have a 3-inch radius roughly on the bottom one. We have bushing heads here. We have greasers on the other side, which you want to use lunkenite, just like what you're using in your Sayaki right now. We have water jet here, one here, and two for the bottom. Like so. On the flood cooler system. We have a manifold right here that you'll hook up for your external water, which goes to your little manifold here for your two here, and your other manifold up here for these two here. This does not come with your own splash pan, you have to provide that yourself. Up here we have a cam roller ram house here with a 6-inch bore weld cylinder. We have two flow controls, one for up, one for down. A weld valve. This here is our Janda 600 weld control. This controller here has 15 different schedules. We'll review that in a little bit. We have our speed controller here, it's digital. Right here we have our input power, which is single phase 440 volts. Right here we have a 200 kVA transformer, Roman, with a 8-point tap switch. We have our dual drive right here. On the dual drive we have slip unit right here. This coupling here is also insulated. We have two more universals going back into my dual drive unit itself. Over here we have my motor, which is a 1 horsepower, 180 volt DC motor. Let's go into a double reduction reducer. For this reducer here we have a chain drive. Right here, we have water in, water out, which is labeled over there. Air input here. We have my slip unit right here. There's a nut that you want to tighten up. Okay, over here, in this view, you can see the slip clutch. What we have here is the slip clutch is right here. We have a nut that you'd want to tighten up if you're slipping too much, or if it's too tight, you want to loosen it back a little bit. This is reduced here to fit your wheels that's out there. So you'll have the same, roughly the same RPM on each wheel. But you do want a little bit of slippage on the upper wheel. You want the bottom one to be the drive, so you want just a little slippage there. Because if it's too tight, if the wheels are a little bit different, then you're going to get a little bouncing effect. But it's nice to have a little slippage. Over here, you see the FRL once again. The samples I welded up on yours, and you'll see me welding in a minute. I'm using 50 PSI on the regulator. My secondary is all water cooled here. I have a tap switch on the bottom. Right now I'm on tap 6. We go to tap 8 on here. So we got plenty of power still. No problem there at all.